Imagine you're dropped into the middle of the Siberian wilderness. No phone, no compass, no roads, just endless, freezing forests stretching for thousands of miles in every direction. If you're like most modern humans, panic sets in within minutes. Without a digital blue dot guiding you on a glass screen, you are functionally blind. We've outsourced our spatial memory to satellites. But 30,000 years ago, your ancestors walked this exact landscape, and they didn't get lost. In fact, they traveled across massive, unforgiving continents, from the frozen steppes of Eurasia to the open, featureless waves of the Pacific Ocean. They did this without a single scrap of paper, without a written alphabet, and without a compass. How? Because to our ancestors, a map wasn't something you held in your hand. It was something you became. Before writing was ever invented, early humans had developed mapping systems so sophisticated, so deeply integrated into the human senses, that they make our modern GPS look incredibly primitive. Today, we're going to look at the bizarre, beautiful, and mind-bending ways ancient humans mapped their worlds. To understand how we first began to put our world onto physical objects, we have to go back nearly 14,000 years to a cave in northern Spain. In 1993, archaeologists excavating the Abonce cave in Navarre unearthed a flat sandstone block, less than 7 inches long and under an inch thick. At first glance, it looked like a mess of random scratches. For 15 years, researchers at the University of Zaragoza painstakingly deciphered the lines, and what they found was breathtaking. This hand-sized rock is the oldest known map in Western Europe. But it wasn't a road map to get from point A to point B. It was a highly localized hunting blueprint. When you look closely at the stone, the lines begin to align perfectly with the surrounding geography. A meandering line carving across the top matches the exact flow of the local river and its 2 tributaries. 2 distinct etched mounds match the silhouettes of the twin mountains visible directly from the cave entrance. But here is the weird, incredibly human detail. Etched onto the hillsides of those carved mountains are tiny, stylized drawings of ibex, wild mountain goats. The artist didn't just map the land, they mapped the resources. This stone was likely used to plan a coming hunt or to tell the story of a successful one. It represents a massive leap in human cognition, the ability to take a vast, three-dimensional landscape, compress it onto a flat stone, and use it to coordinate human behavior. But as impressive as a stone map is, what happens when you have to map an environment that is constantly moving? An environment where there are no mountains, no rivers, and no landmarks at all? Welcome to the Pacific Ocean. Specifically, the Marshall Islands, a massive labyrinth of 29 coral atolls and thousands of tiny islands spread across 1.6 million square kilometers of open water. These islands are incredibly low-lying, often sitting just a few feet above sea level. From the deck of a traditional sailing canoe, you can't see them until you're practically on top of them. Yet, for thousands of years, Micronesian voyagers traveled hundreds of miles between these tiny specks of land with pinpoint accuracy. To do this, they created one of the most unique cartographic systems in human history, the stick chart. At first, European explorers thought these were just decorative art. They weren't. They were highly sophisticated oceanographic maps. The frame was constructed from the stiff midribs of coconut fronds. The small cowrie shells tied to the sticks represented the locations of specific islands. But the sticks themselves? They didn't represent roads or boundaries. They represented ocean swells. When wind blows across the open Pacific, it creates massive, predictable wave patterns. When these swells hit an island, they don't just stop, they deflect, bend, and bounce back, creating unique interference patterns. Marshallese navigators, known as rematos, mapped these invisible wave reflections. The straight sticks in the chart showed the direction of the prevailing currents, while the curved sticks showed how the waves bent as they wrapped around an atoll. But here is the catch that blew Western scientists' minds. The navigators never brought these stick charts to sea. The stick charts were strictly instructional tools used on land to train apprentices. Once you sailed, the map had to live entirely in your mind and your body. When navigating at night or in heavy fog, a master navigator would lie down in the bottom of the canoe hull. By tuning out all distractions, they could feel the subtle, intersecting forces of up to 4 different ocean swells clashing against the bottom of the boat. By sensing which wave was lifting the bow and which was striking the stern, they knew exactly where they were in relation to the distant, invisible islands. They were literally feeling their way through a physical map written on the surface of the water. But perhaps the most monumental mapping system ever devised didn't use stone or wood at all. It used sound. In Australia, Aboriginal cultures have navigated the harsh, arid interior of the continent for over 60,000 years using what are known as songlines, or dreaming tracks. To an outsider, the Australian outback can look like a beautiful but terrifyingly empty void. If you walk into it unprepared, you will die of thirst. But to the First Nations people, the land is a dense, readable book of law, history, and geography. And the index of that book is music. A songline is a sequence of sung verses that functions as a highly precise, acoustic map. As you walk a route, the lyrics of the song describe the landscape features in the exact order you encounter them. One verse might describe a specific red sandstone ridge, the next verse describes a stand of desert oak trees, the next tells you how to find a hidden waterhole buried deep in a rocky gorge. If you sing the song in the correct sequence, the map unfolds step by step before your eyes. If you need to turn around and walk back, you simply sing the verses in reverse order. This acoustic system is incredibly robust. Because the rhythm of the song is tied to the physical pace of walking, the melody itself acts as a mnemonic device. If you can remember the tune, you can remember the distance and direction. Even more incredible, these songlines crossed through lands occupied by entirely different language groups. If a traveler crossed into a neighbor's territory where they didn't speak the local language, they could still navigate. Because even though the words changed, the melodic structure of the song remained the same. The pitch, tempo, and key signature signaled when to turn, when to climb, and where to find water. In fact, this mapping system was so incredibly accurate and well-worn that when European colonists arrived in Australia, they built their horse cart tracks directly on top of the cleared paths of the songlines. Today, major modern highways like the Nepean Highway or the roads crossing the vast Nullarbor Plain are paved directly over the musical maps carved into the earth tens of thousands of years ago. Today, we look at a map to see where we are. But for our ancestors, mapping was an active, sensory relationship with the earth. It required you to look at the stars, listen to the rhythm of the land, and feel the heartbeat of the ocean swells through the soles of your feet. By mapping the world through stone, wave, and song, early humans didn't just survive, they connected with their environment on a level that we are only beginning to understand. So the next time your GPS loses signal, or you find yourself staring at the blue dot on your screen, take a moment to look up. Because the real map isn't in your hand. It's all around you. Thanks for watching. If you want to explore more hidden histories of human behavior, make sure to hit subscribe. See you in the next episode.